Hey, good morning, everybody. This is Mr. Ainsworth. We're going to get into our review over lessons 5, 6, 7, and 8, which covers solving quadratics by factoring, simplifying roots. It also covers solving quadratics by rooting, and also the completing the square technique. So, what I'd like you to do first is get out your TI-84. Have that handy. You could use that if you need it. If not, don't worry about it. You could do it in your head. That'd be awesome. But I'm going to have this over here. I'm going to integrate how to use the calculator properly when it comes to simplifying a root. Okay, so let's get started here. There we go. Okay, so we need to find the factor pair for 175 in order to split the root. So let's set it up. Take 175, draw that vertical line. It ends in a 5, so I'm going to start dividing it by 5. That's probably the easiest thing to recognize. So we enter in 175, and we divide it by 5. And you notice it says 35. So we got 35 here. So 35, well, that's divisible by 5 7 times. 7's prime, so divided by itself. So the factors are over here on the right. Anytime you multiply identical numbers, you get a square. So we now know that 7 times 25 is 175. So what we're going to do is we're going to split the root into a factor pair. So by using these factors here, the 7 and the 25, 7 times 25 is 175. You should know that because 7 quarters is $1.75. So when you split the root, you go root 25 times root 7. Right down in the margin, split the root. Okay, the square root of 25 is just 5, so you have the answer 5 root 7. That's all there is to it. Now, there's another way to think of it too as well. That's probably the simplest way. Let's just leave it as that. Number 2, we're going to do the same thing. We're going to take 216 and we're going to factor it. And whenever you see an even number, divide it by the smallest prime number, which is 2. Half of 200 is 100, and half of 16 is 8, so this better be 108. But if you want to use your calculator, let's interact here. We're going to clear this out and enter 216 and divide it by 2. This will help you out, right? You get 108. So half of 100, half of 16 is 108. 108 divided by 2, half of 100 is 50, half of 8 is 4, so we should get 54. On the calculator, it looks like this. You just divide it by 2 and hit the enter button. 54 divided by 2. It's even. Anytime you have an even number, divide it by 2. And you get 27. And the rest is easy, right? Divided by 3, you get 9. Divide 9 by 3 to get 3. It's prime, so divide it by itself. And you get 1. And the goal is to find the biggest square. Let's write that out. Let's find, all right, the biggest, not the smallest, but the biggest square factor. All right, I see a square here. I see a square here. Whoops, that's supposed to be 9. 3 times 3 is 9. And what I told you guys in class is that 4 times 9, or a square times a square, gives you a bigger square. All right, and that's 36. The only two factors I didn't use are these two in the middle here, the 2 and the 3, and you get 6 there. So what are the factors I need? I need the 6, and I need the 36. 6 times 36 is 216. You can verify that. 6 times 36, 216. See, all these factors on the right multiplied to the original number, right? So those are the factors. So we're going to split the root, and we're going to rewrite it as a root times a root. So we got root 36 times the square root of 6. So we split the root again, and then simplify, and we get 6 root 6, or 6 rad 6. The goal is to learn how to use a factor table to find the biggest square. That is a major concept I've been trying to develop here. Remember, a square times a square gives you a bigger square. Remember that. And the 2 times 3 gives you a factor of 6. It's not a square, but it's a factor. And then just use 6 and 36 for your factor pair. Okay? Same thing here. This one's so small you don't even need a factor table. We know that 9 times 5 is 45, so split the root. Put a times symbol in the middle of each one because, again, this is a factor pair product, okay? Square root of 9 is 3, so you get 3 root 5, or 3 rad 5. On the 112, you may not know what the factor pairs are, so start by dividing by 2. Half of 100 is 50, and half of 12 is 6, so 56 here. Divide by 2. Half of 50 is 25, and half of 6 is 3, so 28. Half of 28 is 14. Half of 14 is 7. Divided by 7 is 1. So where are your factor pairs? Well, I see one here. I see a square here, and I see my biggest square of 16. So here they are right here. 7 times 16 is my factor pair. So I split the root, root 16 times root 7, and I get 4 root 7 or 4 rad 7. All right, so you got to factor the number and use your factor pairs and simplify your roots. Now in the next group here, we want to solve, it says solve the equation by square roots. All right, and the key on that one is to isolate your square term. So isolate your x squared or the square term first. So isolate first. And I'm talking about the x squared term here, or the v squared, or the n squared, or the n squared here. You got to isolate first and then root. Okay, then square root both sides. If you look at your lesson, this is lesson, I think it's 6-7. So take a look at your notes. All right. So pause the video and take your notes if you want to, and I did it in there. All right. So what do we need to do? Well, we need to divide by 2 first, and you get x squared equals 56 divided by 2 is 28. Then square root. Put your plus or minus symbol in, and you get x is equal to plus or minus root 8, 28, excuse me. But again, you got to simplify and split the root again. So let's do that. Root 4 times root 7 gives you 2 solutions, plus or minus 2 root 7. All right, 2 solutions for all of these if they have solutions, okay? Here, instead of square rooting first, you got to isolate the roots. Add 9, and you get v squared is equal to negative 17 plus 9, which is a negative 8, right? Well, let me see. This is positive and that's negative, so it kind of looks like no solution. So go ahead and try to square root if you want. If you do that, you're going to get this, which is not real. I'll do it on the calculator one more time. Take the square root of negative 8, and it tells you that the answer is not real. There's no real solution. No real solution. Why? Because a positive can't equal a negative, okay? Can't happen. All right, continuing here. So what do we have? We got to isolate again. So subtract 7. If you want to use your calculator, clear it out, get it ready. Enter in 295, right? 295 minus 7. Okay, that's 288. So we got 6, n squared equals 288, but we got to divide by 6. And you get n squared is equal to 288 divided by 6. So press divided by 6 here. And you get 48. Then you got a square root, like all the previous ones. As soon as you isolate the square, you got to root it. And you get n is equal to the square root of 48, which needs to be split. So you could, and we need the factor pairs of 48. So let's do that. Let's divide by 2 to get 24, divide by 2 to get 12, divide by 2 to get 6, divide by 2 to get 3, divide by 3 to get 1. And look for your squares. I see one here, here, and I see a bigger one here. So my factors are 16 and 3. So split the root. So we have root 16 times the square root of 3 gives you plus or minus 4 root 3 or 4 rad 3. So again, you're looking for the biggest square when you factor. A square times a square gives you the bigger square. You got to remember that. And then find your best factor pair to split the root. Last one, you got to add 4. So you get 4n squared is equal to 12 plus 4 is 16. Divide by 4. You get n squared is equal to 4. And we know that 2 squared is 4 and negative 2 squared is 4, so n is equal to plus or minus 2. If that was too fast, then go ahead and square root and put the plus or minus symbol in, you get the same result. Okay, now on the more challenging things. This now we got to solve by factoring. Solve by factoring is section 6.5. So if you want to pause the video and take out your notes, go ahead and do that. So you got you want to use the zero product rule. So let me write that down. So zero product rule states that n times m equals 0. That tells you that either n equals 0 or m equals 0. Now we have a zero product here, which means we know that the first factor has to be 0, or the second factor, m plus 2, has to be 0. There's nothing new on the first one, so let's work on the second one. So you got to subtract 2, and you get 5m equals negative 2. Divide by 5, and you get m equals negative 2/5. So once again, two solutions. All right, and number 10 is pretty much the same thing. You got a zero product here. So you set each factor equal to 0. You solve each. You get 2a equals 5. After dividing by 2, you get a is in half. Over here, you get 2, right? 2 minus 2 is 0. So you get a equals 2. Once more, two solutions there, guys. Now we're still solving by factoring, right? So let's play the factor game. So what two numbers multiply to negative 6 and add to a 1? So over here, what two numbers multiply to negative 6 and add to 1? Factors of 6 are 2 and 3, but one of them has to be negative, so let's make the smaller one negative to get a positive 1 down here. And we're going to split the middle term. So n squared minus 2n plus 3n minus 6 equals 0. Now you do a little factor by grouping. So out of the first group here, this is your first group, that's your second group, okay? You got to factor out an n. Out of the second group, you got to factor out a 3. So then after that, you got to factor out the common factor. So that's not correct. What happened here? Oh, yeah, that's correct. The n minus 2 is in common, so you want to n minus 2 times the remaining terms and plus 3. What happened here? Something's not right. Something's not right. Where's my mistake? So oh, that's right. So n plus 3 equals 0. Now we have a zero product. So we separate, make two equations. One has to be 0, right? So 2 minus 2 is 0, so n is 2 here. Negative 3 plus 3 is 0 here, so n equals negative 3. All right, and here we go. Let's play the factor game again. So here on this time, we have to multiply these two. So 7 times 25. 7 times 25 is 7/4 or 175. So what two numbers multiply to 175 and add to a negative 40? Now this might be challenging, so let me give you a little suggestion. The 175 came from 7 times 25. But if I factor 25, I get 7 times 5 times 5. So reordering, I can rewrite this as 5 times 35. 5 times 35 is 175, so those are my factors that I need. Now if I make them both negative, negative 5 times negative 35 gives me positive 175, and if you add them, you get negative 40. The key is factoring. Look for your factor pairs. In this case, I use these two. So I'm going to split the middle term, like I always do. 7p squared minus 5p squared, minus 5p, minus 35p plus 25 equals 0. Let's see here. Factor out a p. So p times 7p minus 5. Factor out a negative 5 here. And we get 7p. Negative 5 times 7p is negative 35p. Negative 5 times negative 5 gives you 25. Obviously, the common binomial is 7p minus 5. So 7p minus 5 times my remaining terms, p minus 5. So p minus 5 and set that equal to 0. Now I got a zero product right here. Okay, so because of that, I set them equal to 0. Solve. And I get my two answers, okay? 5/7 and 5. All right, so make sure. There we go. Make sure you step it out. We've been working on this for 2 weeks, 2.5 weeks. All right, just keep on working with your skills. And remember, there's a video too, so if I go too fast, it's a video. Rewind it. Listen to it again, whatever it takes. All right, in this one, we want to solve by completing the square. So the lead coefficient must be 1. Well, let's write that down in the margin. Lead coefficient, okay, must be equal to 1. It is right here, but not here, so be careful with that. I'm going to add the opposite and get the constant on the right. So I get k squared plus 6k plus blank is equal to 12. 0 and 12 is 12 plus blank. Now here's where the completing the square comes in. I got to take b divided by 2 and square it. b is 6. So what's 6 divided by 2 squared? 3 squared equals 9. So I'm going to need to add 9 to both sides. And then I play the factor game. What two numbers multiply to 9 and add to 6? Well, that's easy, right? Because it's right here, okay? Okay, sorry about that. So two numbers that multiply to 9 are 3 and 3, and they add to 6. So we're going to split the middle term and do factor by grouping. So k squared plus 3k plus 3k, 3k plus 3k is 6k, right? Plus 9 is equal to 21. Factor out of k. Factor out of 3. These are divisible by 3. Now you'll notice the common factor of k plus 3. Let's factor that out. Times the remaining terms, k plus 3. Now that's not a zero product, so we can't split it. Okay, what we want to do is rewrite it as k plus 3 quantity squared equals 21, and let's use roots. Because it's not a zero product, it's equal to 21, so you can't split it right there. You got to square both sides and get k plus 3 is equal to plus or minus root 21. Remember, the square root cancels out the square, giving you k plus 3. Subtract 3, write the result. K equals negative 3 plus or minus root 21, which means two things. Negative 3 plus root 21. And then it also means negative 3 minus root 21. Okay. Now, let's have fun on the last one here. So let me bring this up here a little bit. So this is p equals 5/7. Okay, so we're going to divide, let me back up. The lead coefficient must be 1. Got to remember that in this technique, and it's not 1, it's 4. So the very first thing you do is divide everything through by 4. I'm talking all terms, both sides. So you get n squared minus 4n minus 15 fourths equals 0. And don't freak out with a fraction, just go with the flow. We're going to add 15 fourths on both sides. We get n squared minus 4n plus blank is equal to 15 fourths plus blank. Now the time is to complete the square. So we're going to take your negative 4, your middle coefficient here, your b divided by 2 squared. We're going to take your negative 4, divide that by 2 and square it. We get negative 2 squared, or 4. So I need to add 4 to both sides. Okay. So now at this point, what you want to do is you want to combine the right side. 4 and 15 fourths. Well, let's see here. I've got room right here. 4 and 15 fourths. 4 times 4 is 16. 16 and 15 is 31. So this right side is 31 fourths. So n squared minus 4n plus 4 is equal to 31 fourths. Just go with the flow. Okay, so you just combine and simplify. Okay, now you got to play the factor game. So what two numbers multiply to 4 and add to negative 4? All right, and they got to be negative 2. Negative 2 times negative 2 is positive 4. They add to negative 4 though. So we're going to split the middle term. So you have n squared minus 2n plus 4 is equal to 31 fourths. Just go with the flow. Nothing changes just because you got a fraction. Factor by grouping, n times n minus 2. Factor out the negative 2 equals the fraction 31 fourths. Factor again. equals 31/4. Rewrite it. Okay, now at this point, you square root both sides. And the only thing that you have to know is that you got to square root a fraction, you got to square root its parts. So the square root cancels the square on the left, giving you n minus 2. And you got plus or minus root 31 divided by root 4. You got to square root its parts. Now the denominator is 2. So I get n minus 2 equals plus or minus the square root of 31 divided by 2. So the only thing I need to do now is add 2. And I get n equals 2 plus or minus root 31 all divided by 2. And that's it. Now if you look at the answer, you'll see this right here. Now look at the answer. And these answers look different than this, right? So compare. Believe it or not, they're the same. So let me show you that. So you may not believe me, okay? If you want to compare these two, all you have to do, divide here and divide here. You get 4 divided by 2 plus or minus root 31 divided by 2, which gives you 2 plus or minus rad 31 over 2. So you can see they're the same. Okay? So if you divide a binomial by 2, you just divide both the numbers by 2, simplify, and you're done. So they are in fact the same. Same answers. Which is a good thing. They better be, okay? The answers that I gave you are correct. So that's it. Now, this is a video, right? So you guys need to go back up and remember to review anything that you need to review again. Hear it 2, 3, 4 times, whatever it takes. Practice each one multiple times to make sure you can do it on your own. Perfect practice makes perfect. Okay, remember that. Not practice, just any practice makes perfect. Perfect practice. So you got to repeat these and practice, repeat, right? And practice, all right, until mastery happens. Okay, so do that. You got to put in the time, put in the effort. Practice them, not by reading, but by doing. Actually repeat the examples. And I will see you in my next lesson here, okay? And in fact, I'll see you tomorrow. It's Mr. Ains, we're signing off. I'll see you then.